Hello guys, welcome to my channel. Today we are going to dwell much on grade 12 trigonometry. Before we can try any example on trigonometry, we need to remind ourselves about the knowledge in trigonometry. We need that stack, okay? We start with reduction formula. We start with reduction formula. With reduction formula, we need the Cartesian plane, okay? This is our Cartesian plane, okay? With the Cartesian plane, we got the direction, okay? When you move in this direction, when you start from the positive x-axis moving in an anti-clockwise direction, we are saying that is a positive direction, okay? When you start from the positive x-axis and moving in a clockwise direction, we are saying you are moving in a negative direction, okay? Let's start. Here you are going to have your 0 degrees, okay? Going in a positive direction, when you get here, you're going to have your 90 degrees. When you get here, you're going to have your 180 degrees. When you get here, you're going to have your 270 degrees. When you get here, you're going to have your 360 degrees, okay? Between 0 and 90 degrees, we are saying that we are having the first quadrant. This is our first quadrant, okay? Between 90 degrees and 180 degrees, we are having our second quadrant. That is our second quadrant, okay? Between 180 degrees and 270, we are having our third quadrant. In that order, then in this case, we are going to have the fourth quadrant, okay? In the first quadrant, we are saying that all the trig ratios are positive. When we are talking about the trig ratios, remember we are talking about the tangent, the cosine, and the sine. All of them, they are positive in the first quadrant, okay? In the second quadrant, we are saying sine is what? Is the only trig ratio which is positive. It means that the cosine and the tangent, they are negative. Then in this quadrant, we are having our tangent, which is only positive in the third quadrant. Then here we are going to have the cosine, okay? That's why they say the rule is the cast rule, okay? We are saying that in the first quadrant, we are having angles that are less than 90 degrees. We are having acute angles and we represent them as theta. The theta, they represent an acute angle, okay? When we get to the second quadrant, we are going to have angles which are less than what? Are less than 180 degrees, okay? This is our 180, then less than the angles, they are going to fall in the second quadrant, okay? That's why we represent it as 180 degrees minus the acute angle, okay? In the third quadrant, we're going to have 180 degrees plus theta, okay? 180 degrees plus theta going in that direction. Then in the fourth quadrant, we're going to have what? 360 degrees minus theta, okay? These are going to help us to reduce, okay? They are going to help us to reduce. Let's see how are they going to help us, okay? Let me wrap here. Let's start with the first quadrant. We are saying that we are in the first quadrant, okay? We said that all the trig ratios in the first quadrant, they are positive, and the angles in the first quadrant, they are always less than what? Less than 90. Those are acute angles, okay? We are saying that we are going to have the sine of an acute angle, which is just positive. Then we are going to have what? We are going to have the cosine of an angle there, which is also going to be positive. Then we are going to have the tangent of an angle, which is also going to be positive. In the second quadrant, we are having what? We are having 180 degrees minus the acute angle. Then it means you're going to have the sine of an 180 degrees minus in the acute angle there, okay? The 180 degrees there tell us about the acute angle, okay? This theta here, I said that the 180 degrees represented the quadrant. The theta represented acute angle, which can be a special angle. We will talk about that, okay? When you reduce something of this magnitude, you start by saying you are having 180 degrees minus theta. You ask yourself, in which quadrant does this fall? Okay, when we remember very well, 180 degrees minus, it falls in the second quadrant, and in the second quadrant we are saying our sign is positive. Then this reduces to positive sine of an angle there, of an acute angle. Okay, then we are going to have the cosine of 180 degrees minus in the theta there. Okay, then we still ask ourselves, 180 degrees minus, which quadrant does that one? Obviously it should be the second quadrant. In the second quadrant, is cosine positive or negative? We remember very well that it is negative. Okay, then we are going to have the tangent of 180 degrees minus in the theta there. Okay, we still ask ourselves the same thing. 180 degrees minus it falls in which quadrant? We remember very well that it falls in the second quadrant. Then it's going to reduce to negative tan theta there. Okay, let's go to the third quadrant. In the third quadrant, we are having the sine of 180 degrees plus 1 plus the theta there. Okay, then we still ask ourselves, 180 degrees plus theta, which quadrant is that one? We remember it is the third quadrant. Okay, then in the third quadrant is sine of positive or negative. We remember very well that it gives us the negative. Okay, that's how we reduce it. Then we are going to have the cosine of 180 degrees plus 1 plus theta there. Okay, then 180 degrees plus theta in which quadrant is the third quadrant. In the third quadrant, the cosine there is negative. Then we reduce it to the negative of theta there. Then we are going to have the tangent of 180 degrees plus theta there. You ask yourself, 180 degrees plus theta, which quadrant is that one? Is the third quadrant. Then it reduces to positive tan theta. Okay, then let's go to the fourth quadrant. Okay, let's go to the fourth quadrant. In the fourth quadrant, we are having 360 degrees minus in the acute angle there. Okay, the fourth quadrant, we are having the fourth quadrant. In the fourth quadrant, we are going to have the sine of not 180, sorry, it should be 360. We are having 360 degrees minus in 1, subtracting the acute angle there. Okay, 360 degrees minus in the theta there, it falls in the fourth quadrant. Okay, one. Then in the fourth quadrant, we know our sign is negative. Then it reduces to negative sin theta there. Okay, this is negative sin theta. Then there we are going to have the cosine of 360 degrees minus in the theta there. Okay, 360 degrees minus, which quadrant is that one? Is the fourth quadrant. In the fourth quadrant, is cosine positive or negative? We remember very well that it is positive. Okay, we remember very well that is positive. Then this reduces to positive cos theta. Okay, then we go to the tangent there, 360 degrees minus in what? The theta there. Okay, then we ask ourselves, 360 degrees minus theta, which quadrant is that one? Then we remember very well that it is the fourth quadrant. Then in the fourth quadrant, our tangent reduces to negative acute angle there. Okay, that's our reduction formulas. Okay, then let's go to the co-ratios. We go to the co-ratios. When it comes to the co-ratios, we focus only on the 90 degrees. Our scope is limited to the 90 degrees only. Okay, we focus on the 90 degrees. There we are having the co-ratios. Okay, we are having the co-ratios there. We are still having our beautiful Cartesian plane like that. This is our Cartesian plane, 0 degrees in that order in positive direction, 90, 180, 270 degrees, 360 like that. Okay, when it comes to the co-ratios, we are focusing only on the 90 degrees. Okay, we remember very well that this is our first quadrant, and this is our second quadrant, the third quadrant, and the fourth quadrant. Okay, the angles that we are going to have there in the first quadrant, okay, they are going to be less than 90 degrees. Then here we're going to have 90 degrees minus in 1, minusing theta there, okay? Then this side you're going to have 90 degrees plus the theta there. We go in that direction. Angles which are here, they are always greater than 90 degrees, okay? Yes. Then we focus only on the 90 degrees, okay? Then let's reduce them. Let's reduce them. We start with the first quadrant, okay? With the trig ratios, in our scope, we are only limited to the first quadrant and the second quadrant, okay? And we focus only on the sine and the cosine. That's our scope, okay? We start with the first quadrant. We are going to have the sine of 90 degrees minusing the theta there, okay? The moment you come across the 90 degrees, okay, the moment you come across the 90 degrees, you know that if here you are having the sine, then on the other side, when you reduces, you must have what? The cosine, okay? If you are having the cosine this side, on the other side, you must have the sine, okay? Then you ask yourself, 90 degrees minus theta. Which quadrant is that? Is the first quadrant. In the first quadrant, is sine positive or negative? We remember very well that in the first quadrant, all of them they are positive. Then this reduces to positive cos theta. Okay? If you are having a 90 degrees, if you are having sine, the other side you must have the cosine. Okay? Then you go to the second one, and there you are going to have the 90 degrees minus in one. Yeah? Theta there, okay? The moment you come across the 90 degrees, you know very well that if here you are having the cosine, on the other side you must have the sine there, okay? Then you ask yourself, 90 degrees minus theta, which quadrant is that one? We remember very well, this is our first quadrant, okay? In the first quadrant, is cosine positive or negative? We remember very well that all of them they are positive. Then this reduces to positive sine of what? Of theta there. We are in the first quadrant. We go to the second quadrant, okay? In the second quadrant, we are having what? We are having sine of what? 90 degrees plus theta there, okay? The moment we come across the 90 degrees there, we know whatever we are having this side. If you are having sine, it's going to change it to cosine, okay? Then you ask yourself, 90 degrees plus the theta there, which quadrant is that one? The second quadrant. Then in the second quadrant, is sine positive or negative? We remember very well that in the second quadrant, only the sine is what? Is positive. Then this reduces to positive cos theta there, okay? Then here, we are going to have the cosine of 90 degrees plus theta there, okay? The moment we come across the 90 there, we know whatever we are having here is going to change, okay? Specifically, it's going to change to sine there, okay? Then we ask ourselves, 90 degrees plus theta, which quadrant is that one? We remember very well that is the second quadrant. In the second quadrant, is cosine positive or negative? We remember very well that only sine is positive, then it means the rest they are negative. Then this is going to reduce to negative the sine of theta there, okay? That's all about the co-ratios. We only focus in the first quadrant and in the second quadrant with the 90 degrees only there, okay? Even this one is a co-ratio, but we focus only on the 90 degrees, okay? Then let's go to negative angles. We go to the negative angles there. Let's go to the negative angles. We got the negative angles. We got the negative angles. With the negative angles, like I said, when we go in the clockwise direction, we are heading in a negative direction, okay? We are heading in a negative direction, okay? If I was gonna move in a negative direction, obviously I'm gonna start on the positive x-axis, then moving in that direction. I will start from 0 degrees. When I get here, I was gonna have negative 90 degrees. Then here I was gonna have a negative 180 degrees. Then here negative 270 degrees. Then negative 360 degrees. Okay. Then the angles that we are going to have here when we head in a negative direction or in a clockwise direction, okay, the angles that we are going to have here, they are going to be less than what? They are going to be less than 90 degrees, but they are going to be negative. Are we together there? They are going to be negative. Then here we are going to have our negative theta there, okay? And our scope in most cases is only limited to to this quadrant, to this negative theta there, okay? But we can also have this one, okay? The angles which are here, we are going to have the theta there, okay? The negative of what? Of 180 degrees, okay? Then it goes in that direction. But then in most cases, we are only focusing on this one. But then let's also have these ones, okay? We are saying in this quadrant, we're going to have negative theta minus in what there? The 180 degrees there, okay? Yes. That's all about the negative the negative angles. You can have this ones here, you can have that ones there, okay? If we wish to have this one, we're gonna have the negative of theta there minus in what? Minus in the 180 there, okay? Then we go to double angles. We go to the double angles. We go to double angles. We go to double angles. Let's go to double angles. We are having double angles. With the double angles there, we are having the first one there as the sine of what? Of the double angle there. Obviously, double dimension 2, okay? When you expand this one, you're going to end up having the 2, the sine of theta multiplying the cos of theta there, okay? If you are interested on how did they arrive to this one, you can do a separate video whereby we explain or how is it possible that this one equals to that one, okay? But for now, we just have to know that whenever we come across the sine of 2 theta or of an angle, an unknown angle, you can expand it to 2 sine theta multiplying what? The cosine of theta. Or if you are having the 2 sine of theta cos of theta, you can replace it with what? With the sine of 2 theta there, okay? Then we also got what? The cosine, the double angle of the cosine, okay? With this one, we are having several options there, okay? The first one, we are having the cos squared there of the angle minus in the sine squared there of the same angle, and also we can have the cos squared of theta there minus in 1, and we can also have the 1, the 2, the sine squared theta there, okay? With these ones, the problem is that which one are you going to use and where, okay? You need the knowledge on which one should you choose in what manner, okay? But we are going to dwell much on that one. We are going to do some examples and we will see which one should we have in that particular situations, okay? That is all about the double angles. And again, if you are interested in knowing how did they arrive to this, we can have a separate video whereby we are explaining or how did they arrive to this conclusion, okay? For now, we just have to know that when you come across the double angle of a sine there, you can expand it in that manner. Or when you got something of this magnitude, you can replace it with the double angle, the cosine, okay? Then we can have the compound angles. We can have the compound angles. We can have the so-called the compound angles. The compound angles. With the compound angles there, let's start, okay? We are saying that you are having the sine there of A plus B, okay? A and B, they are different unknown angles, okay? When you expand this one, you would have the sine of A multiplying the cosine of what? Of B plus the sine of B multiplying the cosine of A there, okay? Again, if you are interested in knowing how did they arrive to this conclusion, we can explain. We can have a video on that one, okay? Then we can have the sine of a first unknown angle subtracting the second unknown angle. We will have the sine of A multiplying the cos the cos of the second angle, subtracting the sine B there, multiplying the cos of A there, okay? Then we can go to the cos. With the cos, we will have the cos A multiplying the cos B there, okay? If here they are adding here, you must have your subtraction there, then you're going to have the sine A multiplying the sine B, okay? Then you can have the second one whereby you are having this different unknown angle subtracting, then you can expand it to the cosine of A, multiplying the cosine of B, 18, okay? If here is negative, here should be positive. Then here you're going to have the sine of A multiplying the cos, sorry, you should have the sine here. You should have the sine of B in that order, okay? That's all about the compound angles. Again, if you're interested in knowing how did they arrive to these conclusions, we can have a separate video on that one. But we should know that whenever we see something of this magnitude, we can expand it to that thing, okay? Or whenever you see these things, you can reduce it to have something of this magnitude, okay? Then let's go to identities. We must have identities. We must have the identities. We must have identities there. We must have the identities. We must have the identities, okay? Then the famous identity that we know is this one, okay? Whereby you are having the sin squared theta plus the cos squared theta there being equal to 1, okay? There is a proof on that one, okay? If you are interested, we can do a separate video on that one, okay? Obviously, when you romance the algebra there, you are going to end up with something of this magnitude, okay? You are going to end up with this magnitude, and you can also end up with something of this nature. You can end up with something of this nature, okay? In a shortcut manner, we just say you made the cos squared theta subject of the formula. Here you made the sin squared theta subject of the formula, okay? And you can have this one whereby you are having the tangent of any angle being equals to sin theta over cos theta there, okay? Where you see the tan theta, you can expand it like that, okay? Or when you have something of this magnitude, you can reduce it to that, okay? Even here, when you have something of this magnitude, you can replace it by this. When you have something of this magnitude, you can expand it to that, okay? Yes. Then these are the famous identities that we are going to need for us to solve problems, okay? Then let's go to special angles. We also need the special angles. We need the special angles, okay? Which they are going to help us to reduce in most cases, to calculate without to simplify, I mean, without using the calculator there, okay? The first one, we are having this one. We are having a 90 degrees. Remember that our trig ratios, they only apply in a right angle triangle, okay? Then here you are having the 45 degrees. Here we're going to have the 45 degrees, okay? It means that 45 degrees is a special angle, okay? Whereby here we're going to have 1, the square root of what? Of 2, okay? If you are also interested in knowing how did they end to this, we can have an explanation on that one, okay? Then again, you can have this one whereby you are having what? Here you should have the 30, there you must have the 60 degrees, okay? Here you are having a 1, 2, then here you must have the square root of 3, okay? If you remember very well, if you need the sine of 45 degrees, okay? Remember, by definition, you are having the sine of an angle being equals to opposite over the hypotenuse, okay? If we are using this angle, okay, we are going to say the opposite of this angle is 1. That is one. We are going to have 1, okay? The hypotenuse of this angle, we are going to have the square root of 2 like that, okay? This is what we are going to substitute when we simplify, okay? We can also have the cosine of 45 for 45 degrees there, okay? We choose this 45. Remember, by definition, the cosine of any angle or any acute angle should be adjacent over the hypotenuse, okay? The adjacent of this angle is this one, okay? The side next to it, then you are having what? 1 over the hypotenuse of that is what? Square root of 2, okay? When you are having the tangent of what? 45 degrees, by definition, that the tangent should be what? Opposite over the adjacent, okay? The opposite of 45 is this one. The adjacent of 45 is this one, which is next to it there, okay? Then you are having 1 over 1. That is the one, the tan of 45, okay? The same applies here. If we need the sine of what? 30 degrees here, here's our 30 degrees, okay? And we remember very well that the sine by definition is opposite over hypotenuse. The opposite of 30 there, we are going to have 1 there. You must travel a distance when you are looking for the opposite, okay? Then you are going to have 1 over, okay? The hypotenuse of this angle as well is always the longest side there. Then you are going to have the 2 there, 1 over 2. Then if the cosine of 30 degrees, then this is our 30 degrees. Cosine by definition is what? Adjacent over the hypotenuse, okay? Our adjacent of 30 degrees is this one. This is the adjacent of 30 degrees, okay? Then you must have the square root of 3. The hypotenuse of 30 is that one, okay? The longest side, then you are having 2 there. Then here you must have the tan of 30 degrees. By definition, the tangent there of an acute angle, you must have it as what? As the opposite over the adjacent, okay? Then this is our 30 there. Then the opposite is 1. Then the adjacent, you're going to have it as 1 as the square root of the 3 there, okay? You can also have the sine of 60 degrees, okay? It means whenever you come across this, you replace it by that. Whenever you come across this, you replace it by that. You come across that, you replace it like that. The same applies in this situation, okay? The sine of 60, the word is 60, okay? By definition, sine is what? Opposite over hypotenuse. The opposite, you must travel the distance. Then the opposite of 60 degrees is what? The square root of 3, okay? The hypotenuse of 60 degrees is this one, the longest side. Then you must have 2 like that, okay? Then here we are having the cosine of 60 degrees. So by definition, the cosine should be adjacent over hypotenuse, okay? The adjacent of 60 is this one. Then the one which is next to 60 exactly. Then we are having 1 over the hypotenuse of 60, the longest side, 2, okay? Then we can have the tan of 60 degrees, okay? Tangent by definition is what? Opposite over the adjacent there. Then we must have the square root of 3 over 1. The opposite over the adjacent there, okay? That's all about the special angles, okay? We need that stagger for us to solve problems in trigonometry, okay? We need that. Then we can also need the sine rule, the area rule, the cosine rule, okay? But that's all that we need. Before we tackle any problems, we need to know this stagger. We need that knowledge, okay? We will do a separate video whereby we are doing examples. We are treating examples, okay? Thank you, guys.